Physicists like Albert Einstein and Stephen Hawking dreamed of encapsulating the intricate dance of the cosmos in one grand equation, a theory of everything. Sounds epic, right? But here's the twist. Merging the immense expanse of the universe with the minuscule realm of quantum particles has puzzled scientists for over a century. In this video, we're peeling back the layers of this cosmic puzzle. We'll delve into the elusive quest for a unified theory, exploring the mysterious world of quantum mechanics and the vast reaches of space. Get ready to have your mind blown. Join the conversation by sharing your thoughts and questions in the comments below. And hey, if you're as captivated by the cosmos as we are, don't forget to hit that subscribe button. Have you ever been lying in your bed, thinking about everything? I mean, of course, the grand unifying theory of everything. Let's talk about the big one, the theory of everything. If you're new to this, think of it as the ultimate puzzle in physics, the big challenge everyone's chasing after. Right now, there's a big gap in our cosmic understanding, and whoever solves it will usher in a whole new scientific era. This quest sparks some serious debates among scientists, each striving to leave their mark in history. So what's all the excitement about? Imagine this. The rules that govern the vast universe we see don't quite match up with the tiny world of atoms and particles. Up here, we've got gravity and special relativity doing their thing. But down there, it's a whole different story, with strange phenomena like probability waves and quantum quirks. Let's simplify it. Up here, particles seem solid and tangible. But down there, it's a whole different story. They're just probably hanging out. Here's the catch. Both perspectives have their strengths. Quantum physics nails the tiny stuff, leaving special relativity in the dust. But here's the thing. Quantum physics struggles with the big picture. Planets, gravity, the whole package. And special relativity? Sure, it's handy for satellites, but it's clueless about the quantum strangeness lurking in the micro world. So what's the deal? Scientists believe there must be a grand theory out there, a one-size-fits-all explanation for everything, whether big or small. But here's the catch. Finding it will require a major shift in our thinking, akin to when we moved from Newton's apples to Einstein's space-time. So why not roll up our sleeves and give it a shot ourselves? Get ready, folks, because today's video is all about tackling the big questions, literally everything. But before we dive in, let's set the stage. Now, fair warning, the ideas we're about to explore are pretty mind-bending. But hey, they're grounded in solid theory, so stick with us. Trust us, by the end of this, you'll be nodding along, seeing the puzzle pieces start to fit together. So buckle up and join me on a cosmic journey to uncover the secrets of the universe. Now let's face it, squeezing the entire theory of everything into one video? Not gonna happen. But hey, we can lay some groundwork, right? We're starting off with a model, not the runway kind, but a conceptual framework to make sense of it all. Quantum physics is where we begin, a realm where the math is solid, but the explanations? Well, they're a bit fuzzy. What's the deal with probability waves and waveform collapses? It's puzzling to say the least. So, here's the big question. What do all those fancy equations actually mean on the smallest scales? How does it all connect from the tiniest particles to the vast cosmos? Let's delve in and uncover the answers. Now let's rewind to the past, where others have ventured in search of these very answers. One contender that caught science's attention was string theory, a theory that burst onto the scene in the 70s but ended up leaving us scratching our heads. So, what's the scoop with string theory? Instead of thinking in terms of particles, it shakes things up by suggesting that everything is made of these tiny strings. Like guitar strings, they vibrate and dance, creating waves and harmonies. And here's the twist. This idea sheds light on some of the mysteries of quantum mechanics, hence the name quanta. At larger scales, you might not notice this phenomenon, For instance, you can dim the brightness of a light by placing a semi-transparent shade in front of it, repeatedly halving its intensity. However, if you keep doing this until you reach a small enough level, suddenly you can't go any further. In the world of tiny particles, everything's about being complete, no halfway stuff allowed. Think of it like this. You can have one tiny particle, or you can double that to two, but there's no in-between. The universe prefers things nice and tidy. Take electrons, for example. They're picky about their energy levels. It's either this one or that one, nothing in between. Why? Well, that's the big question. Now let's talk about string theory. It's like strumming a guitar string, where strings can wiggle in special patterns called harmonics. Picture this. The first harmonic is smooth like a wave, while the second has a quiet spot in the middle. You can keep adding more harmonics, each with more energy, but there's never a half harmonic. It's all or nothing, just like in the quantum world. But string theory didn't stop there. It went further. Particles aren't just empty, they carry secrets. Imagine this. The way strings wiggle might unlock all that secret info. If a string wiggles up and down, it could tell us about the particle's charge. But if it wiggles side to side, boom, more puzzle pieces solved. Here's the twist. The more ways these strings wiggle, the more secrets they hold. It's like finding a treasure chest of particle mysteries with each wiggle. Now, if you're into 3D space, you might wonder. Once you've covered up, down, and side to side, there's not much room for new directions without messing things up. And here's the catch. Particles need to change without causing chaos. Like, you should change mass without changing charge, right? So, the smart folks behind string theory came up with a plan. Let's add more dimensions. Welcome to 4D space, then 5D and beyond. But here's the twist. The more dimensions we add, the more doubt grows about string theory being the answer. In the academic world, there are lots of versions of string theory. Depending on who you ask, electrons, quarks, and pals might be described in 26, 21, 11, or 10 dimensions. Yeah, it's a lot to think about and things can get tangled. Now check this out. The blueprint for 4D space is already set. Picture it like this. If you're a flat 2D creature, that third dimension is invisible to you. And for us 3D beings, that fourth dimension is a bit of a puzzle too. But just because we can't see it doesn't mean it's not there. Here's a real brain twister. While we're cruising through our 3D world, we're also zipping through time. That's another whole direction we're heading in, folks. So, what's your take on all this? Share your thoughts below. And if you're into space and science like we are, give us a thumbs up, share this video with your pals, and hit that subscribe button for more mind-bending stuff.